Welcome to another episode of my Python tutorial series. My name is Eliaza and you are watching EA Lego Academy. So today we are going to be looking at object-oriented programming in Python. So I would quickly scroll there. So in our last tutorial video, we looked at modules and anonymous functions. So today we are going to be looking at classes. So I will be going straight to the point. I won't be dancing around circles. If you want to understand what object-oriented programming is, then go back to the very first video I did on the installation setup. There I explained what object-oriented programming is. But to paraphrase and to summarize what it's all about, object-oriented programming is when we say a programming language satisfies three basic properties, which are polymorphism, encapsulation, and inheritance. So today we are going to be looking at classes. So classes, these are containers that allow us to hold multiple lines of code and functions together in order to execute a program or multiple programs. So they are similar to functions, but the difference is that classes, they act as bigger containers that allow us to hold functions and multiple lines of code as well. So we have the init function. So we said this is a function that is created by Python and executed the moment a class is executed. It is a function used by Python to create parameters for a class when we choose to create one ourselves. So, in other words, in order for your class program to get executed or to run, if you don't create an initializer or a constructor, Python would create one for you the moment you attempt to execute the code in a class. That is what the initializer does. But if you choose to create one yourself, then you would need to supply parameters. So we said the initializer is used to hold parameters for a class. That's what it's used for. Then when you are trying to execute that class, you would need to pass arguments for each parameter inside the initializer. That is it. So it is also called a constructor. So note, a default one is created when we don't create any ourselves. So let's look at the self parameter. So this is a parameter that specifies that a variable or function belongs to the class it is created in. It points to the class it's in. So if you create a class and that class has code, now for the record, we treat code, every type of code in every programming language, as an object. So if we are creating an object or objects in a class. In order to specify that that object belongs to the class, you will need or you would need to prefix a self parameter before the name of that object. That's just what we're trying to say. So that self is used to specify that that object belongs to the class. So note, we don't assign the self parameter a value. So we don't give it a value because it is used to specify that an object belongs to a class. That's that. So now we have a program below that justifies that. So I have a class called test, and this class has two attributes. So I will say this. Now we looked at variables and we looked at parameters. Now variables, parameters and attributes, they are the same thing. They are they are empty containers that we assign values to, but their different names is determined or is dependent on where we are using them. So if I am using an empty container that can be assigned a value outside of a function or outside of a class, we call it a variable. If I'm using an empty container that can be assigned a value in the parenthesis of a function or in the parenthesis of an initializer, then we call it a parameter. Now, if I'm using an empty container that can be assigned a value in the body of a function or a class, then we refer to it as an attribute. So that's it. So because I am using an empty container that can be assigned a value in the body of a class, that's why I called it an attribute. Now, the none, this none you are seeing here is a keyword, or it's an inbuilt statement in Python that we use to specify that that variable does not have a value. So that is what it is used for. So now what I'm trying to do here is that I created two attributes that belong to this class. Now inside this initializer, in its parenthesis, you would discover that I created two parameters. Now these two parameters I created here, they represent these two parameters here. Now this name and age represent these two attributes, so self.name, self.age. So like I said, the self parameter is used to specify that an object belongs to the class. So it is saying that this name and age belongs to this class. And also this self parameter here also belong, like this self parameter is saying that this initializer belongs to the class. Now I have a function here inside this my class. This function also has, okay, still recording. So this function also has a self parameter. So remember, you don't give a value or an argument to the self parameter. The self parameter is what we use to specify that that object belongs to the class. So here we are saying that this run function belongs to this class. Now you will notice that I used the self.name and self.age to make a sentence instead of the name and age. The reason is because this initializer has two parameters that are acting as the parameters for this class. That is why when I executed this class, I passed two arguments for those two parameters. Now, because those two arguments now represent those two parameters, or because these two parameters are now represented by these two arguments, we can also say that self.name and self.age have also been given those arguments as their values. That is why I can instead come here and use self.name and self.age to replace name and age. So that's that. And because this function is inside this class, in order for me to execute this function, I will have to go through this class to run this function. And because this function is returning back a value, I would need to use the print function before I can see the code that this function is returning. So when I copy this code and paste, I'm going to put the print function before this test. So what you want to do, go to your PyCharm, make sure that you are inside your project. So I would open up that project for my tutorial. This is another project, so I'll have to navigate to my main project that I have been using for this tutorial. Okay, so now I'm sure by now we already know how to create a new Python file. So you come here. So now this IDE, for those of you watching this video for the first time, this is the PyCharm IDE. IDE stands for Integrated Development Environment. So it is an environment that we use to write Python code. So I downloaded it. If you want to know how it was downloaded, watch my first video on the installation and setup of both the Python interpreter and the PyCharm integrated development environment. So go back and watch it to follow or to have proper knowledge. So this tutorial, this particular episode that I am doing is for object-oriented programming. So you come here, right click on your folder, come to new, then Python file, and I will just call it OOP Python, OOP Python. So you go back to your file, copy from here down, and you paste it. So I will put the print function before the test so that it can execute this sentence that this function is returning. So I will change it to current file and run. So you see we get hello Alex, you are 34. So that's how you can run your code in a class. Now the next thing you want to do is to look at instance of a class. So this is a variable we create and we assign a class as its value. So you create a variable and then you give that variable a value which will be a class. So we have done this concept. We are just repeating concept in programming, but in different ways. So if you can still remember when we looked at data structures, lists, tuples, and dictionaries, you would remember that we represented the list, dictionary, and tuple classes with variables. So when we represented them with variables, those variables were implicit representations of those classes. So go and check my previous videos to better understand the concept I'm trying to say. But this is just the same thing I'm doing. I created a class and I'm assigning that class to a variable. So that variable is now a representation of that class. So for simplicity, I did not change the code. I just repeated it, but this time around, I created a variable that now represents my class and used that variable to access the run function instead of using the class name directly like I did before to access the function. So it's still the same thing I'm doing, but I'm creating a representation of the class. So you paste it and run, and you will discover that you get the same thing. So that's how it works. Minimize. So let's look at setting default value for an attribute. So this is when we assign a value to a variable created in the body of an init function. We can see this displayed below. So now I have already explained what attributes are, what variables and parameters are. I said that the three of them mean the same thing, but the reason why they have their respective names is because of the manner and method in which they are being used. So when we say setting a default value for an attribute, it simply means that you give an attribute in either the body of a class or an initializer a value. You assign it a value. You don't have to wait till you execute that class, the program of that class, before you give it a value. That is what we are trying to say. Now you will notice that now I did not change the code, it's still the same code. I still used the same code, and here I created an attribute and I assigned it a default value of the integer data type 84. So I did not wait until I executed this program before giving a value to self.score, just like I did to name and age. So I just did it right away. Now you will notice that I created another function and I'm using the value of that attribute self.score to make a sentence. So this will print out you had a score of 84. Now you would notice that as I am executing the codes inside both functions, you will discover that I'm not giving any argument to these two parameters self. I already said the reason why I am not doing that. I said the self parameter is used to specify that a function, that this object belongs to that class. In the case of a function, this function belongs to the class. In the case of an attribute, this attribute belongs to the class. So that is what it means. So they don't have arguments, you don't give them values. You would notice that although this initializer has the self parameter, when I executed the class, there isn't a third argument for that parameter. I only gave two arguments for the second and third parameter. So if you copy your code, you will discover that it will print out, hello Alex, you are 34, you had a score of 84. So that's what you would get. So another thing that you should note is that no matter the number of functions I create inside this class, all those functions would forever have access to the values of these attributes inside the initializer. That is one concept you should take note of. So you copy your code and then you come here and then you paste it. So run. See, we have those two sentences printed out. So you comment out your code on to the next. Now the next one is modifying attribute value directly. This is when we assign a new value to a variable in the body of an init function, or we increment the value of a variable in the body of an init function without using a function to do it. So we can either modify the value of an attribute in the body of an init function, or we can increment it. So we only increment when we are looking at numerical values. So we do it directly. We don't use a function to do it. So I will show you how you can use a function to also carry that out, or to carry them out. So now I still did not change the code, still the same code. I just copied and pasted it. But you would notice that after I created the instance of my class and used that instance to execute the run function, you would notice that I first changed the value of 84 to 90 before I executed the function that makes a sentence with the value of score. So don't forget, the original attribute name is score. We are only using self because we are trying to say that that attribute belongs to the class. Now, because we know that the self parameter is used to refer to the class, and we know that when we create an instance of a class, that instance also represents the class, it is safe to say that that instance is also doing the same work as the self parameter. Now, one thing you should know is that the self parameter cannot be used outside of the class. It can only be used in the class to which it is referring to. So it can only be used inside the class. So you will notice that I changed the value to 90. So you see we have test.score, which is the same thing as self.score. So in this case, self is acting as a representation of your class. So I said test.score equal to 90. So this has changed the value of 84 to 90 before I now decided to execute score report, and you will discover that it will print out you had a score of 90. So just copy your code and paste it in your PyCharm environment, and you will discover that you have those respective sentences printed out. You had a score of 90. All right. So when you are done, comment out your code also. Now, the next thing we want to look at is modifying an attribute value through a function. So here we just looked at how we can modify an attribute value directly. This is doing it directly. So now we want to see how we can use a function to do the exact same thing that we just did. So that is what we want to do and look at. So modifying an attribute value through a function. So this is when we assign a new value to a variable in the body of an init function, or we increment the value of a variable in the body of an init function using a function to do it. So just like the same definition I gave here, but doing it directly, we want to look at the exact same definition but using a function to do it. So mind you, we have not yet looked at incrementing. We have only looked at modifying the value, an attribute value directly. Now we want to look at modifying the attribute value using a function. So now still the same code, I did not change anything. So you would notice that in addition to the previous two functions, run and score report, I have added a third function called score update. Now this function score update has its own attributes. We know that the self parameter, although an attribute, we don't give it an argument during the function execution. So you would notice that this function has a parameter which would be given an argument during its execution. Now that parameter is going to act as the new value given to self.score. So remember I told you that every function inside a class can access all the parameters within the initializer. That is why this function called score update is having access to self.score. And you can see that I'm saying self.score is equal to new score. So whatever argument I give to new score during the execution of score update automatically becomes the new value of self.score. So you see that I created my instance, executed the first function run, then executed this function score update. Now, something you should take note of: the order in which you write functions inside a class does not matter or does not determine the order in which you would execute them. Now you see that although I wrote score update before score report, I ended up executing score update before score report. So I executed score update before score report because I wanted the new value assigned to self.score to be reflected in the execution of score report. That is why. So after I created the instance, I executed the run function, then I executed the score update and gave it a value of 90 before I now executed score report. So with that being said, copy your code and go and paste it in your Python. So you copy it, come here and then paste. So you will discover that it would print out the same result that we got here in the previous code. So you see that we now have you had a score of 90. So it has changed the value of self.score from 84 to 90. That's how it works. So having done that, comment out your code so we can proceed to the next code. So now let's look at incrementing an attribute value directly. So this is when we increase the value of a variable in the body of an init function without a function. So kind of like it's kind of similar to that first definition we gave, whereby we modified the value of an attribute without using a function. So also I didn't change the code. I wrote the same code, but you would notice that after I created the instance of this class, I executed the run function, and then after that I decided to increase the value of self.score to 12. So I added 12 to the previous value. So this is just the same principle I explained to you. I said that while we are inside the class, self is used to refer to the class. But when we come outside of the class, the instance we create is now used to refer to that class. So now this test.score represents the previous 84 I had to get the new value of test.score. So it will now be equal to test.score is equal to test.score plus 12. So this test.score is this 84 here. So that would make it 96 before I now decided to execute this function that makes a sentence with self.score. So you just copy your code, and then you will get you had a score of 96. It would also print out this sentence from the run function, like how it has been doing before. So you paste your code and then you execute it. So that is how it works. So when you are done, comment it out. To the next one, incrementing an attribute value through a function. So this is when we increase the value of a variable in the body of an init function with a function. So the exact same thing that we just did, we are trying to do it again, but this time using a function. So yet again, the same code, I did not change anything. I just only added a new function to it. So you will discover that I have a function that has a parameter which I would give a value to during its execution. So you can see that here I said to get the new value of self.score is equal to the previous value of self.score plus the parameter. So when I execute this function, I would give an argument to this parameter, and of course the value of that argument would be added to the previous value of self.score to make it its new value. So you would see that I executed this function before score report. So I told you that the order in which you write your functions in your class doesn't matter. What matters is which one you execute first. So you will discover that I gave it an argument of 12 in order to keep the result of this code consistent with the result of the previous code. That is why I did that. So you just come here and you copy your code and run, and you will discover that you would have the same result that you got with the previous code. So I will just click on play and you would see that we have the same thing. So when you are done, comment it out, highlight it down. Okay. Okay, so the next thing we want to look at is inheritance. So this is when a class has access to the code inside another class. So you create a class that has access to all the code inside another class. The class carrying out inheritance is referred to as the child class, while the class being inherited from is the parent class. So now these are okay. I still gave the same function, the same code rather. So the same code from the previous program we just ran, I created a class, the same class, and then I created another class that is going to have access to all the functions inside this my test class. Now, the class carrying out inheritance was given a name of child test. Now, this is how you specify a class carrying out inheritance. So the class that is carrying out inheritance, you write its name first, then you open a parenthesis and write the name of the class that is being inherited from inside that parenthesis. Now, there's something you should know. The class carrying out inheritance from the parent class should have the same number of parameters that the parent class has. It is not a must they must have the same name. The child class can have parameters totally different from the parent class, but the bottom line is that it must be the same number of parameters. That is what we are trying to say. So it must be the same number of parameters. Now you would notice that after creating self attributes for the parameters, you would notice that I used a function called super. Now, before I explain this function, there is also something that I want you to also note as well that I did not talk about. Now, it is not a must you must write attributes first before you now use the self parameter on them. Now, even though these two attributes were not in existence before, if I came here and I said self.name and self.age, Python would automatically recognize that the reason why I am saying self.name and self.age is because I'm trying to say that these attributes belong to the class. That is it. So it doesn't matter whether you create them before or not. As long as you do self.name, self.age, it knows that those attributes belong to the class. Even self.score, it belongs to the class. Okay. So now back to this super. So this super is used in traditional object-oriented programming languages like Java. When we say super, we only use it when we are trying to replace when we are trying to use the child class to replace an already existing function in the parent class. That is it, or in programming terms, override. So I want to create a function inside this child class that has a name as one of the functions inside the parent class. That is only when I use the super function. Then after you write it like that, you now come here and say dot init and still write the name of the two parameters inside the child class, not the parent class. So to just reiterate what I said, it is not a must that I must write name and age to match the names of the parameters inside the parent class. The only thing that matters is that they should be the same number of arguments inside the initializer. So now you can see that I've created an instance for this child class. So I've created an instance for the child class. Now, because I said that this instance can access all the functions in the parent class, you would notice that I came immediately right away to execute the run function, and I also executed the score report function from the parent class. So you notice that I gave arguments for the parameters of my child class. So this will print out the same sentence. We would get hello Alex, you are 34, and it will print out you had a score of 84. So mind you, the child class is having access to this parameter called self.score. So you just come here, copy it down to the last part, copy it, and then you paste. Then after that, you can execute your code and you would see that you get the results. Okay, so when you are done with that, you comment it out. So to expand more on what I said earlier before we continue, I said that an object-oriented programming language is a programming language that must satisfy three basic properties, which are polymorphism, encapsulation, and inheritance. So these are the three properties that I said a programming language should satisfy. Now let me explain more on them. So when we say inherit, let's start with encapsulation. So when I say encapsulation, this simply means hiding a portion of your code from the rest of your program. That is what it means. Hiding a portion of your code from the rest of your program. you would notice that before we looked at inheritance, let's go back, you will discover that if I decided to come here and created a variable, so hold on, we'll go to PyCharm and we will do that. So before I even continue on that, I would uncomment out the previous code before this inheritance and explain that. So now if I come here and create a variable, maybe info, and assign it a value, or maybe information, and maybe I want to execute this code from this function inside here, I come here and say info is information. You will discover that Python would underline information, sorry, when I say info rather, Python would underline info because it was created in this function, not this function. So when we say encapsulation, it simply means hiding a portion of our code from the rest of our program. So it simply means that this score report and this inc score cannot access this info that was created in my run function. And if I still go ahead to execute this program, ignoring the red underline by Python, you will discover that it will tell me name error or name not defined. So we get name error, name info is not defined. So that is it. So that's what we mean by encapsulation. And also, since we now know what encapsulation is, hiding a portion of our code from the rest of our program, this now brings me to explain inheritance, which I just did. So I just did that. I said is when you create a class that has access to the code created inside another class. So that is what we mean by inheritance. Now we also looked at polymorphism. So polymorphism is the ability for your program to exist in more than one forms, multiple forms. So a single program to exist in multiple forms, and we are going to explain that. So we would look at that. We will do a practical implementation of that. But before we get to that, let's look at attributes and methods for child class. So we are done with this. We saw that we could create a child class, and then that child class could access the code inside all the code inside the parent class. So let's look at how we can give attributes to a child class. So you would see that it's still the same code. I did not change anything, the same code, but you would notice that in addition to the child class, I created another attribute and gave it a string value. So you make sure that before you use the super.init function, you have written all the attributes inside that is in the body of the initializer of your child class. You don't want to write attributes after the super.init function. So you can see that the child test class has another function called course.desc, course description. So it's making a sentence with this attribute that has physics as its value. So you will discover that after I created an instance of this child class and used that instance to execute the functions in the parent class, I then went ahead to use that instance to execute the function in my child class, cos DESC. So it will print out, so you offer physics. So just copy your code and paste it. Then we would look at polymorphism and then the last concept for classes. So you paste your code and then you run. So you see we get, so you offer physics. So this is just a repeat of the code from the parent class. Of course, we know that the child class has access to all the code in the parent class. I think I pasted it in the wrong place. It's supposed to be after this. It's supposed to be after here. Okay. So comment it out. You comment it out when you are done. So after that, let's look at the next one. Overriding methods from the parent class, which is also known as polymorphism. So this is when we carry out polymorphism by creating a function in the child class that has the same name as a function in the parent class and then running the one in the child class. So you would agree with me that there would be no need for you creating a function in the child class that has the same name as a function in the parent class if the contents of those functions are the same. There would be no need. So it's only if you are trying to change the content that was previously in the function in the parent class to some different content while it is being used in the child class. So you would agree with me that it's only when they are going to have different content, that is when it would be necessary to create a function in the child class that has the same name as a function in the parent class. So let's look at that. So you will discover that, so I did not change anything, still the same code from the parent class and still the same code from the child class. The only difference is that I created a new function called score report that has the same name as the function in the the same function, not a new function. So I created this my score report again in my child class, and this time around the content is different from what was inside my parent class, hence the name polymorphism. So I created an instance of my child class, so just change it to self so that to avoid over complication. So change it to self. So I'm targeting, since the child class has access to every code in the parent class, I'm accessing the self.score attribute 84 and I am changing the value to 82, and I am using I'm using that new value to make a sentence. So you will discover that although I created an instance for my child class and that instance has access to all the functions in the parent class, but because I created a function that has the same name as a function in my parent class, the instance of my child class would end up executing that function that is the instance of my child class would end up executing the function in itself instead of executing the function in the parent class. So my instance or the instance of my child class would execute this score report and leave out this score report in the parent class. So it still executes the other functions like before, the run function and the course description. It is the only code that would be different would be that of score report. So it would print out score now seems to be 82 since I have changed the value to 82. So you can just copy your code and go and paste it. So you see we get score now seems to be 82. So you offer physics. So you can just comment out your code. All right, the next one is instance as an attribute. So this is when we create a variable, not an. So this is when we create a variable in the body of an initializer init function inside a class, and then we assign it a class as its value. So from the name, instance as an attribute. So you create an attribute in the body of an init function or an initializer, and that attribute would also be acting as the instance of another class. So let's look at the example below that explains this. So now these are totally different classes that I created. So I created a class called first prog and another class called second prog. Now both classes have initializers and functions in them. So now I didn't have to waste time. I didn't waste much time. So what I did here was that if you notice, this second prog class has two parameters in its initializer, and there is a third attribute after the name and age attributes. It has a third attribute called self.first. Now, this attribute here is acting as the instance of this class called first prog that I created. And because this class called first prog has two parameters, you would notice that in the parenthesis of this my class as it's acting as the value of this attribute, you would notice that I gave two, or I passed two arguments that would be arguments for these two parameters. So in order for me to execute this function, if I want to go through this class to execute this function, I would need to create an instance of this class second prog, and after creating an instance of that class of this class, I would need to use that instance to access first directly. So remember I said that the self parameter is only used when we are inside a class. The moment we come outside of a class, we have to use the instance of that class to access whatever object or code is inside the class. So now, since second prog is the name of my class, I created an instance called second. I now used that instance to execute this function like normal. So it will print out, hello there, Alex, you are 33 years. Now, the main thing we are trying to do is to execute this function from this class. So since I have created an instance of this my second prog class, I can then use that instance to access the first attribute. Now, the first attribute is acting as an instance of this class. That is why I now used the dot notation to access the message function, and this would now print out you attend Harvard and you study biology. Taking note that Harvard and biology are arguments for school and course. So you copy your code and then you paste it. Paste it. Paste. So now, before the reveal, at the front of this second, you come here and say print, and then you close your parenthesis. So I forgot to do that. So to print out, hello there, Alex, you are 33 years. And then this one too would come here and execute this function in the first prog class. So you can see we get that you attend Harvard and you study biology. Hello there, Alex, you are 33 years. Okay, so that brings us to the end of this episode. If you enjoyed my video thus far, please like my video, and if you are passing by, please do well to subscribe, because it's your subscription that would encourage me in making more content like this. And please do well to share if you feel that this video would be of importance to your friends and families. So just before I close, please, if you feel like my video if you feel like you have a problem with my video, just leave a comment in the comment section. Please, just leave a comment. It doesn't take anything to give a feedback. You understand? You can just like the video if you feel it was informative. If you don't like the video, if you don't like the manner in which I'm using to teach, leave a comment. Please, it will do me a lot of good. I don't know how to buttress or how to stress this point, but it's very important. The main reason why I'm doing these videos, all these my videos, is to get subscription and to get likes, so that the algorithm, I can get more subscribers and I can make a living from this video. I'm not just doing it to pass time. Fine, I enjoy the fact that you guys are giving me your audience, but please, it is very discouraging when I spend hours making a video, or when I take time out of my time to make this video with a lot of stress, and I don't get any feedback, I don't get likes, I don't get nothing. Please, please, please help me out. So till we meet again next time, goodbye for now.